All right, folks. Let's take a look at another example of how we can analyze these bodies in static equilibrium. But I'm not going to use the table this time. The table of supports and their reactions and all that. I'm just going to sort of intuitively come up with these things. So the thing that we're looking at, we want to determine the support reactions on this. So this member AB has got a force applied, it's got a couple moment applied, but it's being held in static equilibrium with a roller at B and a collar here at A. And we're told that it's fixed to the collar at A, but that the collar can slide along the shaft. So the first thing we should do here is draw a free body diagram of this. So first we should draw the body, which I have here. We need to add this 900 Newton force, 900 Newtons. We need to add this couple moment, 500 Newton meters. And we can look this up in the table if you want, but let's just think about what this support is actually doing. The only thing that this support can do is prevent this member from moving downward, right? It stops this thing from moving downward. So this support is pushing downward on this wall right here, right? The ground, the floor right here. This support is pushing downward on that, which means that the ground is pushing back up on that support. I'm going to call this force at B. These rollers cannot stop any motion in the horizontal direction, right? If this member had some tendency to move to the left or the right, these rollers would just start rolling. It would just move in that direction. It cannot stop that motion from happening. If we were to pick this member up, these rollers would not stop that from happening. The only thing that they can do is prevent downward motion, so there's an upward force. The reactions here, so this is one of our reactions. These reactions are always just what the support can prevent from happening. So let's take that and think about what's going on at A. At A, we have a collar that's on this shaft, smooth shaft. Because we're fixed, the member is fixed to this collar, and the collar is on this shaft, this thing cannot rotate. This support at A is preventing this member from rotating. And when I say rotating, I mean rotating in this sort of 2D plane, either this way or this way. So if it's preventing that rotation from happening, we need to add a moment reaction. A moment reaction is just a prevention of a rotation. We're told that it can freely slide vertically. So this thing can go in the vertical direction, right? I think we can see that. This collar can sort of freely slide on the shaft, which means that there will not be a vertical force here because this support cannot prevent that from happening. It'll just allow that motion. But this collar can't move through this shaft, so there will be a force in the horizontal direction, which I'll call AX. So this is our free body diagram. These are the forces or the reactions that these supports can add to this member, because these are the motions that it can prevent. Hopefully that makes sense. This roller prevents a downward motion, so it has an upward force. This collar prevents a horizontal motion, so it has a horizontal force, and it prevents a rotation, so there's a moment reaction. Now that we have the free body diagram, we can just sum equations like we always do. We can sum. Actually, I'm going to come back to that. Let's sum forces first. Let's sum forces in the x direction, set that equal to 0. In the x direction, we have this AX reaction, and that's it. There's nothing else going on in the x direction, so AX is equal to 0. we should still draw AX because this support can support an AX. It just happens that there's no need for it right now. If there were a horizontal force applied, then there would be a non-zero AX. We can sum forces in the y direction, set that equal to 0. We have a 900 Newton force downward. And we have force at B upward, plus FB. And that's it. They're the only forces that have a y component. We're going to set that equal to 0, and we know that FB is equal to 900 newtons. Nice. Okay, so now we've got these two. Now we just need to sum moments about any point to figure out what this moment reaction is. I'm going to say let's sum moments about, this might not be the easiest choice, but we'll sum moments about A. Set that equal to 0. So the moment reaction causes a moment about A. This 500 Newton minus 500 Newton meter couple moment, that generates a tendency to rotate everywhere. Then we also have a minus 900 times 1.5 meters and a plus 900, this is for BY, times, what is this? This is going to be 3 meters. 3 takes us from here to here. And then we got to add plus cos 45. Kind of running out of room here. And that's it. Those are all the things that generate a moment about A. So the moment reaction to A is moment is 1 minus 1486 Newton meters. And that's it. So I think if we just look at this figure that's given, I think this looks pretty intimidating. It's hard to know where to start. It's hard to know how to attack this problem. Your first step, your first thought should always be free body diagram. What do we draw a free body diagram of? We want to know the support reactions on this member, so we have to draw the free body diagram for this member. Once we draw this, again, it might be difficult to know where to start. Summing forces is easier, so I think that's a good place to start, a good place to think about this. And it turned out to be not too difficult to find the forces. The moment, a little bit more complicated, but yeah, there's not, I don't think anyone expects you to know exactly which equation to use just from looking at this free body diagram, but you need the free body diagram before you can start deriving equations. And then I think the strategy is just to keep thinking about equations until you come up with one that has a single unknown. That's a good place to start. That's all. I hope this helps.